In this video, I'm going to talk through questions 6, 7 and 8 of the Unit 1 assessment. I'll put a link in the description to the video for when I start going through question 7 and question 8 so that you can go straight to those questions if those are the ones that you want to look at. Okay, so question 6. Fizzy drinks like lemonade contain dissolved carbon dioxide and preservatives such as citric acid. This means they are acidic and can weaken tooth enamel. Part A says suggest a pH value for lemonade. So for this one you just need to use the information in the question. It tells you that fizzy drinks like lemonade are acidic, and you should know that acidic liquids have a pH of less than 7. So any one value less than 7 would be absolutely fine. For example, you could say pH 6. Part B says indicators are substances which change colour when in solutions of different pH values. The table below gives information about two indicators, bromothymol blue and methyl orange. So you've got a table for bromothymol blue here and a table for methyl orange, and it gives you different colours. So it tells you that bromothymol blue is yellow if it's in a solution with pH below 6, and it's blue if it's in something with pH above 7.6. Methyl orange, the colour would be red if the pH is below 3.1, and the colour would be yellow if the pH is above 4.4. So the pH of 3 substances were investigated using both indicators. The results are shown below. So you've got substance A, B and C, and you've got different colours with the different indicators. And it says, part I, which substance must be an alkaline solution? Okay, so you should know that alkaline means pH is greater than 7. So you're looking for something which must have a pH of greater than 7. Well, if you look at the different colours, most of these colours are for pHs below, so say below 6, below 3, even above 4.4. Above 4.4 could still be an acid because the pH could still be between 4.4 and 7. So really, we're looking for something, if it is definitely an alkali, it must have a pH above 7.6. That's the only one of these colours that will tell us it's definitely an alkali. So we're looking for something that's blue with bromothymol blue. So colour with bromothymol blue, yellow, yellow. C is the only one that is blue with bromothymol blue, which means it must be an alkali. If we look at the other ones, A and B are both yellow with bromothymol blue, which means their pH must be below 6, which means they are definitely acid solutions. And then part 2 says, suggest a possible pH for solution B. Well, solution B is yellow with bromothymol blue, so its pH is below 6, but it's also yellow with methyl orange, so its pH is above 4.4. So if you give any value between 4.4 and 6, I'm giving you the mark for that question. Typically, you might have suggested something like pH 5. I think that would be fine. But if you'd said anything from 4.4 to 6, that was okay for that question. Okay. Okay, question 7 says a student carried out the following experiment. So you've got barium chloride solution plus sodium sulfate solution is making barium sulfate solid and sodium chloride solution. And it says in this reaction, a solid was formed from two solutions, and you just have to name the type of reaction taking place. So hopefully you recognise this as a precipitation reaction. That was just a case of either knowing it or not. You need to make sure you revise the acids and bases topic if you didn't get that. Okay. And then part B says the equation for the reaction is, and it gives you an equation here, so you've got barium 2 plus in solution, plus 2 Cl minus ions, 2 chloride ions in solution, plus 2 sodium ions in solution, plus a sulfate ion in solution, makes, and then you've got your barium sulfate solid and your chloride ions and your sodium ions still in solution. And it says rewrite the equation showing only ions that react, i.e. without spectator ions. So remember, the spectator ions are the ones that are the same and also in solution on the reactant side as well as the product side. So the ones that have changed here, you can see your barium has gone from AQ to solid, so that one has changed, so that's not a spectator ion. The chloride, on the other hand, it's Cl minus AQ on this side and on this side, so that has not changed, and that's a spectator ion, so I'm going to take that out of the equation. Sodiums as well, sodiums are the same, AQ, Na plus AQ on the left and Na plus AQ on the right. There's 2 on each side as well, so that means I can just cancel them out, take them out of the equation. But then our sulfates, they're AQ, they're in solution on the reactant side, but then they formed a solid on the product side, so they have changed. So the only ions, once I've put a line through the spectator ions here, the only ions that we're left with are the barium plus sulfate. Okay, so most of you I think got this one correct. You have to be careful with this type of question with your state symbols, and actually look, you see how careful you need to be. I've just made a mistake there. So if you are including state symbols, they must all be correct for you to get the mark. So I would have lost a mark if I hadn't spotted that one there. But if you want to, you can just ignore state symbols. You can just not include state symbols. So if you don't include any, that would be fine. But if you include them, they must all be correct for that question there. Okay. Final question then. Question 8 says, read the passage below and answer the questions that follow. So you've got a passage there about potassium. I'm not going to read the passage out. I'll give you a moment if you want to pause the video and have a read through it there. Okay, so question 8a says, state why the human body requires a regular intake of potassium. So this is one of these questions where you've not been taught this in chemistry, right? We haven't learned about why the body requires a regular intake of potassium. But if you see something you think, I have no idea, then chances are the information is going to be in the question. So for this one, you just need to look at the information in the passage, and potassium is an essential element for almost all living things. The human body requires a regular intake of potassium because humans have no mechanism for storing it. So I think, again, almost everyone got that, which is great. Okay, part B was a little bit more difficult. So part B says calculate the number of moles of potassium in 100 grams of raisins. Okay, so you're asked to calculate the number of moles, and it's in 100 grams of raisins, and it's the moles of potassium. So when you're asked to calculate the number of moles, remember you've got your 2 different possible equations to use. You've got N equals CV, and you've got N equals M over GFM. Now, it's talking about 100 grams of raisins, but remember, we're not trying to calculate the number of moles of raisins, we're trying to calculate the number of moles of potassium. So this is where this question's a little bit trickier, because you've got to pay attention to the way the question's written. So it says calculate the number of moles of potassium in 100 grams of raisins. And up here in the passage, it says raisins contain 0.86 grams of potassium in every 100 grams. So in 100 grams of raisins, we know that we have this amount of potassium. You should recognise that G, grams, represents a mass. So what we're told about potassium in raisins is we're told that the mass is equal to 0.86 grams. A lot of you got a little bit mixed up with that. You would have still got 1 mark though if you do this question based on 100 grams. Okay, so now that we've got the mass of potassium, we know we can't use N equals CV because we don't have a concentration or a volume, but we do have a mass. And if we've got a formula, or if we've got the name of a compound, we should be able to work out the GFM. So this is a little bit more difficult again because we don't just have a symbol or a formula. So we are going to need to use N equals M over GFM, because there's no way we can use N equals CV. So the GFM, when we're asked about potassium, you should know, and this is much simpler than just writing a formula, you should know that for elements, we either use just the symbol or we use the symbol with a little 2 if it's a diatomic, but potassium's not a diatomic, so it's just K. So we just need to do 1 times the GFM of potassium, which is, sorry, the relative atomic mass of potassium, which is 39, and that just comes from page 7 in your data book here. So if you looked for the GFM, or if you tried to calculate the GFM of potassium, that would come out as 39. So the difficult bit of that question was figuring out what information you needed to use. So our GFM of potassium is 39 grams per mole. And now that we've worked that information out, it should be nice and easy to use N equals M over GFM to work out the final answer. So you're going to do 0.86 divided by 39. The mass was 0.86 grams, GFM was 39. And then that works out as 0.022. So you can either round that to 2 or 3 decimal places. I think I'm just going to round it to 2 decimal places. So that comes out as 0.02 moles. Okay, so you did get 1 mark if you used the wrong mass in that question, but you did do the sum correctly. Okay, question C says state the colour of the flame which would be seen when potassium burns. You may wish to use page 6 of the data book to help you. I'm going to be honest, I gave you a little bit of extra help there by giving you the page number. You wouldn't normally get that, but we haven't actually covered flame colours yet, so I thought I'd give you a bit of extra help there. So page 6 of the data book, finding the flame colour for potassium. I think almost everyone got that, and the answer was lilac. And then part D, this was again a little bit more difficult and not quite so well done. So D says write the ionic formula. D says write the ionic formula of potash. Now again, potash is something that you've never heard of, but again, if you come across something like that you've never heard of in chemistry, you need to look at the information in the question. So it says write the ionic formula of potash. So we're assuming potash must be some kind of chemical, and we're going to look for information about it in the passage here. So here we go, saltpeter, potash. Potash, it says, is potassium carbonate. So naturally occurring salts of potassium such as saltpeter, potassium nitrate, and potash, potassium carbonate. So that gives us the information we need to know to write the formula. So potash is actually an old-fashioned name for potassium carbonate. Okay, so it says write the ionic formula. Usually the way I've taught you to do this would be to just write the normal formula first and then the ionic formula. So potassium is in group 1 and has a valency of 1. Carbonate ends in 8. It's on page 8 of the data book. Okay, and if you find carbonate in the data book here, you'll see it's got the formula CO3 2-. The 2- means it's got a valency of 2. Okay, so it's CO3 and it has a valency of 2. So if we do our crossover rule here, we're going to get a formula of K2CO3, and there's only one of those, so we don't need to put any brackets in. But then that's just the formula, that's not the ionic formula. So to write the ionic formula, I need to think about what the charge would be. So again, potassium is in group 1. It's got a valency of 1, and it's a metal. So the valency of 1 means it needs to lose 1 electron to get a full outer shell. So a potassium ion would have a charge of 1+, but because there are 2 of this whole thing, we need to put brackets round the symbol for potassium, because there's not only 2 potassiums, but there are 2 K+. And then we need to put in the charge of the carbonate ion, which again we saw on page 8. So CO3 was CO3 2- from the data book there. So that is your ionic formula. And remember, in the ionic formula, the charges should even out. So if you just double check that, so you've got two lots of 1 plus, so you've got 2 plus altogether, and then you've got a 2 minus ion as well. Okay, so if you want to, for this one, you could maybe just score out your working or double underline your final answer.